Hello students, so in this video we will be discussing the questions from the last part of calculus, that is application of derivatives, right? So f maps R to R, the first question says f maps R to R be a twice differentiable function such that f double dash of x is greater than 0 for all x belongs to R, and f dash of a minus 1 is equals to 0 where a is a real number, and let g of x is equals to f of tan square x minus 2 tan x plus a such that 0 less than x less than pi by 2. Consider the following two statements: g is increasing in this interval and g is decreasing in this interval. For that we need to find the derivative, right? Okay, so whether statement 1 is true or false we have to check, right? So we will break down the given information. So he has given that f double dash of x is greater than 0. Now what does this mean? This implies that f dash of x is a strictly increasing function, correct? As per the definition, correct? No, say if f dash of x is a strictly increasing function, f double dash of x is greater than 0, that we can say, and f of x will have a minima at, or we can even interpret in terms of maxima and minima, but let us go with this definition because we need in terms of increasing and decreasing, right? Okay, and now he has also given that f dash of a minus 1 is 0. Okay, that's fine. Now okay, we have tan square x minus 2 tan x plus a, right? So he has given that g of x is equals to f of tan square x minus 2 tan x plus a. So if I want a minus 1, f dash of a minus 1, so we will do one thing, we will add and subtract 1. We will add and subtract 1 so that I can generate a minus 1 in my question. So what do we get? We can write this as f of tan x minus 1 whole square plus a minus 1, right? This is g of x. Now since I need to find whether it is increasing or decreasing in this interval, first let me differentiate. So g dash of x will be f dash of, as per the chain rule, yes, f dash of this into derivative of the inner part, that is derivative of 2 times tan x minus 1 is 2 times, sorry, derivative of tan x minus 1 whole square is 2 times tan x minus 1 into derivative of tan x is secant square x minus 0, derivative of minus 1 is minus 0, plus derivative of a minus 1 is 0 since it is a constant, right? So we have f dash of, ultimately what do we have? F dash of tan x minus 1 whole square plus a minus 1 times 2 times secant square x into tan x minus 1. I hope you are with me till here. Now see, he is given that g is increasing in this interval and decreasing in this interval. For that, and we still have not used this information. See, f dash of a minus 1 is 0. F dash of, see, given that f dash of a minus 1 is equal to 0. Now, tan x minus 1 whole square will be greater than 0 for all x belongs from 0 to pi by 2. Right? It's anyways a square, perfect square. It can never be 0. Okay, it can be greater than or equal to 0. At pi by 4 it will be equal to 0, but otherwise it will be greater than or equal to 0. I hope you are with me. Okay, now we will do one thing. Case 1 will be, we will take this interval 0 to pi by 4 and we will see whether g is increasing or decreasing. For all x belongs to 0 to pi by 4, what will happen? Achha, we need to know whether this value is positive or negative firstly. Now since f dash of a minus 1 equal to 0 and f dash of x is strictly increasing, right? So now listen to this statement clearly. For all x greater than a minus 1, can I say f double dash of x, sorry, f dash of x will be greater than 0 for all x greater than a minus 1? Yes, because it's a strictly increasing function. At a minus 1 this value is 0. So for any value of x greater than a minus 1, this value should be greater than 0, and for all x less than a minus 1, f dash of x should be less than 0. I hope you are with me, right? So in this case 1, that means tan x minus 1 whole square is either 0 or greater than 0. That means this value is, so that means f dash of tan x minus 1 whole square plus a minus 1 will be greater than 0 for all x belongs to 0 to pi by 4. I hope you understood this part, because at pi by 4 this value will be 0, but for all other values except pi by 4 this value will be positive. Positive plus a minus 1 will definitely be greater than a minus 1, For all such values, f dash of this should be greater than 0. So now let me write down the case 1 now. So case 1 says, again, for all x belongs to 0 to pi by 4, g dash of x is, once again, what is that? f dash of tan x minus 1 whole square plus a minus 1, and if I remember, it was 2 secant square x into tan x minus 1. Now think about it. For all x belonging from this in this interval, this value is positive. Which value? This value is always positive, we just discussed, and this value should also be positive since it's a perfect square. What about tan x minus 1? See, tan x is an increasing function. Tan x, the graph is something like this. At pi by 4, the value is 1. So for all x belongs from 0 to pi by 4, for all x belongs from 0 to pi by 4, this value should definitely be less than 1. Means you take any value between, for all x belonging to 0 to pi by 4, tan x will be less than 1. Correct? Now, since it's an increasing function, that means this value will be negative. That means therefore g dash of x is less than 0. Correct? Now, for all x belonging from 0 to pi by 4. And what is it telling in the question? He is telling that g is increasing. No, g is not increasing, g is decreasing in the interval. And the next statement says g is decreasing in pi by 4 to pi by 2. Okay. Now case 2. For all x belonging from pi by 4 to pi by 2. Again, let us write down g dash of x. That is f dash of tan x minus 1 whole square plus a minus 1 times 2 secant square x times tan x minus 1. Right? Now, this value is anyways positive. Correct? No, because x is not equal to pi by 4 for any other value of, as per the previous explanation. Again, this is understood. I think this is positive. I'll not bore you, and this value also will be positive. And now this value will be positive because for any x, for all x belonging from pi by 4 to pi by 2, tan x should be greater than 1. Right? That means this is positive. Therefore, g dash of x is greater than 0. That means g of x is increasing. That means g of x is increasing, but he's telling g of x is decreasing. So this statement is also false. That means statement 1, neither 1 nor 2 is true. So that means option 1 should be the correct answer. Right? I hope you understood this question. If you have not understood, please rewind the video and watch once again. Now let us go to the next question. Next question says, let f be a differentiable function satisfying f of x is equals to this, and let g of x, he has given something, x belongs to R. If P and Q are respectively the points of local maxima and local minima of G, then the value of mod P plus Q, right? So, let f be a differentiable function satisfying this. So, it is a numerical or integer type question, dear students. So, in this question, now differentiating this directly won't help because we have e power x minus t into f of t. So, directly we cannot apply Newton-Leibniz theorem. So first, I think to solve this question, we need to find the value of f of x first, and then we can proceed in this question. So we will do one thing. We will write f of x as 1 minus 2x. See, this integration is with respect to 2, so we will take e power x outside the integral. So we will write this as integral 0 to x e power minus t into f of t dt. Right? Now let us differentiate with respect to x on both sides. So we get f dash of x is equals to derivative of 1 is 0, derivative of minus 2x is minus 2. Now we need to apply UV rule here, product rule here. Derivative of e power x is e power x as it is into this part as it is plus e power x you treat it as constant and differentiate this part. If I differentiate this part, what will I get as per the Newton-Leibniz? So we can write now e power minus x into f of x, right? I hope you know Newton-Leibniz theorem, and derivative of 0 is anyway 0. Now, okay, now here the interesting thing is this part is equals to f of x minus 1 plus 2x. Am I right? Can I write like that, this integration? That means instead of this part, what can we write? We can write that as f of x minus 1 plus 2x. So we can write this as f dash of x is equals to minus 2 plus, instead of this part we can write f of x minus 1 plus 2x plus e power x into e power minus x is e power 0, which is 1, plus f of x. So we have ultimately f dash of x is equals to minus 3 plus 2x plus 2 into f of x. Now let f of x is equals to 1. I think from here we can easily solve. We can write this as dy by dx is equals to minus 3 plus 2x plus 2y Now dy by dx minus 2y is equals to minus 3 plus 2x. So now let us find the integration factor. Integration factor should be e power minus 2 dx, e power integral of minus 2 dx, which will be e power minus 2x. So therefore general solution will be y into e power minus 2x is equals to integral of e power minus 2x into 2x minus 3 dx, right? So we get y into e power minus 2x is equals to, if I apply by parts, take this as the first function and this as the second function as per the abbreviation I laid. A is algebraic, so this should be first and this should be the second function. So we get first function into integral of second function, which will be e power minus 2x by minus 2 minus integral of derivative of 2x minus 3 is 2 into integral of e power minus 2x is e power minus 2x by minus 2 into dx. So this and this gets cancelled, minus into minus becomes plus. So we get, if I take this minus sign inside the bracket, we get 3 minus 2x divided by 2 into e power minus 2x. Now we have integral of e power minus 2x, which is once again minus e power minus 2x by or plus divided by minus 2 plus c, right? I think I am correct. Integral of e power minus 2x should be e power minus 2x by minus 2. Perfect. So now we will do one thing. We will multiply with e power 2x on both sides. So we get y is equals to 3 minus 2x by 2, and if I multiply with e power 2x, I will be getting here minus 1 by 2 plus c into e power 2x. Now I think the boundary condition is given. So yeah, I think we are done it. Probably replace x with 0, we get f of 0 is equals to 1 minus 0 plus integral 0 to 0. F of 0 should be equals to 1. That means when x is equals to 0, y is equals to 1. So that means 1 is equals to 3 by 2 minus 1 by 2 plus c into e power 0 is 1. So we get 1 is equals to 3 minus 1 is 2, 2 divided by 2 is 1. So therefore c is equals to 0. That means therefore y is equals to 3 minus 2x by 2 minus 1 by 2. So if I simplify it further, we get 3 by 2 minus 1 by 2 is 1 minus x. That means f of x is equals to 1 minus x. That this is the given function. Now this itself could be a question, but he is asking us to find the value of g of x, the local maximum and local minimum of g of x. For that we will write g of x first. So g of x is integral 0 to x, if I remember, and it is f of t plus 2 whole power 15 t minus 4 whole power 6, f of t plus 2 whole power 15 plus t into t times into t minus 4 whole power 6 times t plus 12 whole power 17, t plus 12 whole power 17 dt, right? Now if I differentiate it as per the Newton-Leibniz theorem, we get g dash of x is equals to f of x plus 2 whole power 15 into x minus 4 whole power 6 into x plus 12 whole power 17. I hope you are aware of Newton-Leibniz theorem, right? Derivative of this x into, and we have to replace the variable t with x, right? Derivative of x is 1 and derivative of 0 is 0, so minus 0. What is f of x? 1 minus x. So we ultimately get 1 plus 2 is 3 minus x whole power 15, x minus 4 whole power 6 and x plus 12 whole power 17, right? This is it. So g dash of x. Now the first derivative, so we will take minus outside, we will get minus of x minus 3 whole power 15, x minus 4 whole power 6, x plus 12 whole power 17, right? Now as per the first derivative test, let us check the sign of g dash of x. So what are the critical points here? Critical points are minus 12, 3 and 4. See, x minus 4, the degree is 6, which is even. So there will be no sign change. At x equals to 4, the value will be 0 for g dash of x, but to the left of 4 and to the right of 4, there will be no sign change in g dash of x. Now let us come with this part. Forget about the minus sign here, okay? Forget about the minus sign here. When x is greater than 3, as per the Wavy-Curvy method, we should be getting a positive value here. But since we have a negative sign, so this becomes negative. Now this becomes positive, this becomes negative. I hope you have understood this, students. And if you are not comfortable with this, I would say you can proceed with the second derivative test. Keeping the time in mind, I am going with the first derivative test. This is generally considered as easier. Now if the rough graph should be something like this. Means at, see, g dash of x is negative, that means it is decreasing. G of x, this is rough graph. rough graph of g of x. So g of x is decreasing when x is less than minus 12, so it's something like this, and g of x is increasing when x is greater than minus 12, and g of x is decreasing when x is greater than 3. So that's how the graph looks like. So that means as per the sign change, if you know the first derivative test, at x equals to minus 12, we get a local minima, because the derivative as per the first derivative test, the sign changes from negative to positive, and at x equals to 3 we get a local maxima. I hope you have understood this. That means what is P here? Points of local minima and local maxima. Acha, P is the point of local minima, Q is the point of local maxima. So what is P? P will be minus 12 and Q will be 3, I think, right? What is he asking? Mod of P plus Q. That means mod of minus 12 plus 3 should be mod of minus 9. That means mod of minus 9 is ultimately equal to 9. I think this is the answer. I hope you have understood this, students. Let us go with the next question. Next question says, consider the following 3 statements for the function f maps from 0 to infinity to r defined by f of x is equals to mod log x to the base e minus of mod of x minus 1. See, the graph of log x is something like this. This is the graph of y is equals to log x to the base e, and this value is 1. That means when for all x belonging from 0 to 1, log x to the base e will be less than 0, right? That means now let me define the function. F of x will be, it will be, acha, now when x belonging from 0 to 1, this value will be negative, right? When x is belonging from 0 to 1, that value will be negative, right? So we'll get minus log x to the base e, and when x is between 0 to 1, for example 1 by 2, again this value 1 by 2 minus 1, that will still be negative, so negative into negative will be positive, so we get plus x minus 1. We are just opening the modulus function, dear students. Understood? That means I hope you have understood this, right? And for all x belonging from 1 to infinity, right, or we can even include closed interval here, not an issue, log x will be greater than 0, right? Correct, no? As per the graph, and x minus 1, mod of x minus 1 will also be positive, so we will get log x to the base e minus x minus of x minus 1. Now what is he asking? Acha, f is differentiable at all x greater than 0, f is increasing, f is decreasing. For all these cases we have to differentiate. F dash of x will be, derivative of minus log x is minus 1 by x, derivative of plus x is plus 1, and acha, here we can write this as 0 less than x less than 1. Now here we are writing 1 less than or equal to x less than infinity, right? Now here if I differentiate log x, we will write 1 by x, derivative of minus x is minus 1, derivative of plus 1 is plus 0. Acha, now here the interesting thing is 1 less than or equal to x less than infinity. Is this step correct, dear students? It is not correct, because we need to check the differentiability at 1. So we will directly not introduce the inequality. If you are introducing the inequality, we are declaring that f dash of 1 exists, right? For that we will do one thing. We will check the differentiability. To check differentiability, we will find left hand derivative at x equals to 1. That means f dash of 1 minus. For that part we will be taking this function, that will be minus 1 by 1 plus 1, so it is 0, and right hand derivative at x equals to 1 we will get f dash of 1 plus, that means we will be taking this function, so we will get 1 by 1 minus 1, which is 0. So since left hand derivative is equals to right hand derivative, we can say therefore f of x is differentiable at x equal to 1, and therefore f dash of 1 exists. Now we can introduce the equality. I hope you have understood this. This is a very important step. That means the first statement, yes, this is true. Now what about the second statement? F is increasing in 0 to 1. Acha. In 0 to 1, this is the derivative, right? In 0 to 1, this is the derivative. For all x belonging from 0 to 1, f dash of x is equals to minus 1 by x plus 1, minus 1 by x plus 1, which is nothing but minus 1 plus x by x, which is nothing but x minus 1 by x. Now you take any value, you take example, you take 1 by 2. If you take x as 1 by 2, numerator will be negative, denominator will be positive. If you take x as 1 by 2, so f dash of x will be negative. So you can check for any other value of x belonging in this interval, f dash of x will be less than 0. So therefore we can say f of x is increasing. Or you can try with wavy curvy also, you will be getting the answer. So f of x is increasing. But what is it telling? Yes, f of x is increasing in 0 to 1. Okay, let us once again check. F is, okay, what are we getting? Oh, sorry, f dash of x is less than 0. So f of x is decreasing. I'm sorry, f of x is decreasing. And what is he telling? F of x is increasing. That means this is false. And what is the third statement? F is decreasing in 1 to infinity. Okay, 1 to infinity, we will be taking this interval, this function 1 by x minus 1. So for all x, now for all x belonging from 1 to infinity, f dash of x is, what is f dash of x equals to 1 by x minus 1. 1 by x minus 1, that means 1 minus x by x. You take any value of x belonging in this interval. Even if you take x as 1.1, this value will be 1 minus 1.1 will be negative. So therefore f dash of x is less than 0. Again this f of x is decreasing here. Right? So what can we write? F of x is again decreasing. Yes, this is true. That means statement 1 is true, statement 3 is true. So what should be the answer? This cannot be the answer, this cannot be the answer. No, this cannot be the answer, this should be the answer. 1 and 3 are true. So therefore this is the right answer. Thank you for watching this video, dear students. Meet you in the next one.